What is a percentile? Let's look at an example of 50 students' scores on an algebra test. So we're going to specifically look at the student who scored 83. We notice here, if we count the dots, that 10 students scored 83 or above, and 40 students scored less than 83. So we say that 83 points is at the what percentile? Is at the, so let's figure this out. 40 out of 50 is 80%. We say it's at the 80th percentile because 80% of the students scored less than 83 points. So that's what a percentile means. Now, what scores at the 98th percentile? Well, the 98th percentile means that 98% of the students scored less than this score. So 98% is equivalent to 49 out of 50. So if we want to find the score that 49 out of 50 students scored less than, it would be the top score here. So 97 points is at the 98th percentile. Now, a graph that goes very well with percentiles is the cumulative frequency graph. Because what a cumulative frequency graph tells us is the percent of the data that lies below any of the values on the x scale. So in this situation, the x scale represents the median household income of an entire state. The data was collected for the 50 states in the District of Columbia. So we want to look at California. California has a median household income of $57,445. And what percentile is this at? So we're going to look up 47. Well, this is 45 and 50, so this is 47.5, which is pretty close to, I'm sorry, I want 57.5. That's about right here, 57.5. So I'm going to go up to here and over to here, and we see that California's median household income is about at the 80th percentile. That's approximate. It's a little hard to read this graph exactly, but that's pretty close. Okay, what does this mean in the context of the problem? It means 80% of the states, or about 40 states, had median household incomes lower than that of California. Now, what is the 25th percentile for this distribution? Well, here we would look then at the cumulative frequency, find 25%, which would be about right here, go across and go down. So it looks to me like about $46,000 would be the 25th percentile, and this is also known as the first quartile, Q1. So quartiles are actually percentiles. Q1, Q3, the median, those are all percentiles as well as quartiles. Now the next thing we're going to do is think about how could we translate this information into a frequency histogram. So what we have to do is think backwards from cumulative frequency to regular frequency. So what we notice is as we go from 35 to 40, we see that we go from about 0 to maybe 2%. This is 10% here, so maybe 2% of the data falls in that category, at or below 40%. When we go from 45 to 50, we see a change. From about 2% to maybe about 22%. So the cumulative is 22% at 45. but that's a growth of 20%. When we go from 45 to 50, you can see we go from about 22% to maybe about 50%. So we're at 50% now, which is a change of 28%. When we go from 50 to 55, now at 55, if I go up and over, so up to 55 and over, I would evaluate that at maybe 72%, 73%, say 73%. So we see a change of about 23%. Then from 55 to 60, we go up to 60 and go across. Oh, I didn't draw that one very straight. This is hard to eyeball this, especially as you get farther away from the y-axis. So it looks like maybe about 85%. So now we see a change from 73 to 85 of about 12%. Then at 65, we go across, and it looks like about 92%. So from 60 to 65, make that look a little better. From 60 to 65, you see about, what did I say, 95%. So we see a change of about 10% here. And then when we go from 65 to 70, now we're up at 100%. So we're at 100%, so we had a change of 5%. So in a cumulative frequency graph, the height of the graph represents the cumulative frequency, but in a histogram, the height of the bar represents just the frequency, or the relative frequency in this case, in that bar. So now we have bars like this. So here, if I were to draw this graph here, mark it off, 35, 40, 45, 50, 55, 60, 65, and 70. This is, I will label this as median income in the state. Median, should say household income, I guess. Median household income in the state, and it's measured in thousands of dollars. So like when you see 50, it represents $50,000. And then we're going to have our relative frequency over here. So relative frequency, and in percents, we notice the highest percent we have is about 30. So 30, 20, 10, and then we'll make this 5. So here's 30, 20, and 10. So our first bar from 35 to 40 is at about 2%, so it'd be about right there. Then we have a bar at 20% here. Then a bar at 28%. Then a bar at 23%. A bar at 12%. 10%. And 5%. Now what I want you to notice is how the two graphs are related. If you notice, the 3 steepest sections on the graph correspond to the 3 highest bars. Notice this very low slope over here from 35 to 40 is the lowest bar. So the steeper the graph in the cumulative frequency graph, the higher the bar in the histogram. Now, could we also find a box plot from this graph? Yeah, let me erase some things because it's gotten rather crowded on here. Let me erase some things. I know you can't do that, so I'm sorry about that. For finding a box plot, we need to know the minimum value, which is clearly 35, the maximum value, 70. So here's our minimum and our maximum. And then we need to find the median and Q1 and Q3. So the median would occur at the 50th percentile. So we go across, and it looks to me like the 50th percentile is at 50. Then we already found the 25th percentile. Remember we did the 25th percentile and found out that was about 46. And then we need to find the 75th percentile, which would be about right here. Looks to me like just slightly more than 55, so maybe 57. So it looks like that would be our 5-number summary. So making a box plot, let me kind of scoot this up a little bit, extend my page. So we need to go from 35 to 70. Let me make that just slightly straighter. I'm kind of going uphill here. So make my, I don't know, I think I have to use my magic pen here. Use my magic pen. Magic pen lets me make a line and it automatically straightens it for me. Ah, there we go, lovely. Now back to regular pen. Okay, so 35, 40, 45, 50, 55, 60, 65, and 70. Okay, so we have our median is at 50, Q1 is at 44, Q3 is at 57. So notice our IQR, our interquartile range, is going to be 57 minus 44, which is 13. Then we have our maximum at 70 and our minimum at 35. Now, we didn't check for outliers, so we should probably check for outliers. I kind of doubt 35 is going to be an outlier, but let's just check both. So remember, we take 1.5 times the IQR, and we add that to Q3, and we subtract it from Q1. So the IQR is 13, 1.5 times 13. So let me just do this quickly. So we're going to have 44 minus 1.5 times 13, and we're going to have 57 plus 1.5 times 13. If I get anything less, if 70 falls outside that range, or if 35 falls outside the lower boundary, so if 75 falls beyond the upper boundary or 35 beyond the lower boundary, then we have an outlier. So I'm just going to quickly pause and calculate those numbers. You can do that. I got 24.5 and 76.5, which means we have no outliers. So that is a summary then of percentiles, quartiles, and how they both show up in the cumulative frequency graph.